What's the average session duration? 1 column out of 20. 5 million rows. Answering that question can cost you as little as 26 megabytes, or as much as 1.1 gigabytes. Same rows, same answer, same machine. Here's why. Disks don't hand you individual values, they hand you blocks. Whatever else is sitting in that block arrives, whether you asked for it or not. So the only question that decides the cost of your query is the data you need next to each other on disk? Let's make this concrete first, with 4 rows. A row store packs each record's fields together: id, user, duration, country, then the next record right after. A column store packs it the other way: every id together, then every user, then every duration, then every country. Same idea, now at real size: 20 columns, 5 million rows. Here's query 2. Select the average of 1 column from the table. A row store writes every record's fields together: row 1's 20 columns, then row 2's 20 columns, and so on. To answer this query, you have to walk the entire file, stepping over 19 fields you don't want, just to reach every 20th value. An index doesn't save you here. Averaging every row means touching every row's value. The only index that would help holds just this column. That's a column store in miniature. Now the same query, against a column store. Every column's values sit together, all 5 million values of the column you want, in one contiguous run. The other 19 columns live somewhere else entirely. You never even open the block they're in. Columnar layout buys you more than fewer bytes read. Same type values sitting together compress hard. Dictionary encoding for repeated strings, delta encoding for sorted numbers. Each column chunk can carry its own statistics too: minimum, maximum, how many nulls, so the engine skips whole chunks it already knows can't match. And security gets simpler. Encrypt or restrict just the sensitive column without touching the rest of the row. Scan 5 million rows to answer query 2, and a row store forces you to read over a gigabyte. A column store that reads every column anyway still wins, just by decoding faster. But a column store that reads only the column you asked for needs 26 megabytes. 41 times fewer bytes for the exact same answer. Row stores have their own home turf beyond a single indexed lookup. Updating one full record is one write to one place. A column store doing the same update touches every column's file. And plenty of real workloads want most of the row anyway, rendering an order, processing an event, not 1 column out of 20. That's why OLTP databases default to row storage: frequent whole record writes, read back whole. But that's only one kind of query. Here's query 1. Select everything, where ID equals 4. With an index, not necessarily the primary key, a row store jumps straight to that block. 1 read. That same index exists in a column store too, but it only points to a position. You still have to open every column's blocks to rebuild the row. Row stores aren't the wrong answer. They're the right answer to a different question. The cheapest bytes are the ones you never read. A row store can't avoid reading them. A column store can, but only if its layout matches how you read and how you write.